Hello everyone, I'm back again with another lecture. In this lecture, I want to do some examples about applications of um, derivatives of trigonometric functions. First question says, write the equation of a tangent line to the curve of y equals -2 sine x at a point where x equals pi over 6. So we know that to write the equation of any straight line, let alone tangent line, we need to know the slope of that line. So I'm going to try to find the slope of tangent first. And slope of tangent, m sub t, is actually f prime at a, where a stands for the x-coordinate point of tangency, as we know from before. So basically, I need to find f prime at pi over 6 to find the slope of the tangent. To find f prime at pi over 6, I need to know the derivative first. So I'm going to quickly differentiate this. I'm going to say y prime equals derivative of -2 sine x, which is -2 cos x clearly. So f prime at pi over 6 now would be -2 cosine of pi over 6. And cosine of pi over 6 radian is actually cosine of 30 degrees, which is square root of 3 over 2. So when you multiply -2 by square root of 3 over 2, you end up with negative square root of 3. So this is the slope of the tangent line to the curve of y equals -2 sine x. Now, we know that y minus y1 equals m times x minus x1 is the equation of any straight line. So instead of slope of tangent, I can plug in -√3. Very clear. Instead of the x-coordinate of point of tangency, I can plug in pi over 6. Very clear. But what is the y-coordinate of point of tangency? I don't know yet. So I'm going to find it. I'm going to say f at pi over 6, which is the y value of the point of tangency. It's going to be -2 sine of pi over 6. So sine of pi over 6 is 1/2 times -2 is going to be -1. So now the puzzle is clear that y sub 1 is -1. So now all I have to do is to simplify what I got here. So -√3x plus pi over 6 times √3. And this positive 1 moves to the other side, -1. So this is the equation of the tangent line we were looking for. Tangent line to the curve y equals -2 sine x at a point where x is pi over 6. That's one example. Another example, it says find the second derivative of x squared cos x. Okay, so I'm going to start with the first derivative, obviously. So x squared times cos x, the first derivative, we know that we have a function here, quadratic function here, and we have a trigonometric function, a cosine function right there. So this reminds me of u times v. That is a product. You should be recognizing these products by now. When you have the product of two functions, you're going to apply product rule. Okay? So derivative of first times second plus derivative of second, which is negative sine x, times first. Okay? So can I further simplify or something? Maybe I can factor x out. I'm just thinking. So x is the common factor. So I get 2 cos x minus x sine x. All right. So this is what I end up with. Now, to find the second derivative, which is the derivative of the derivative, I notice that I have another product here. This is a new v, and this big expression is the next function. So u times v, again, another product. So I have to apply product rule again. So I'm going to go derivative of first, which is 1, times second is going to be the same function v, and then plus derivative of second times first. So that will be x times, now this is the derivative of that expression. Derivative of cosine is -2 sine x. And over there, I have derivative of -x sine x, which itself is a product, isn't it? So it will be derivative of first times second, which is negative sine x, plus derivative of second times first, which is cos x times negative x. So that's being negative x cos x. Okay? So we have negative x times cosec, that's times sine x. This is my basically u, and this is my v. Okay, it's a product, isn't it? So derivative of first is -1 times sine x, would be negative sine x, plus derivative of second times first, which is derivative of sine x, that is cos x, times first, which is negative x. So we end up with negative x cos x. Okay. Now, can I simplify this? That's the question. Well, I see I can collect like terms. These two add up to -3. So I go 2 cos x minus x sine x plus x times -3 sine x minus x cos x. This is actually the derivative of the derivative, so that's y double prime. Okay. And let me see, if we expand, we get -3x sine x. This is another -1x sine x. That would be -4x sine x. Collecting like terms, nothing important. 2 cos x at the beginning. And the last one, -x squared cos x. Okay, so this is the final answer. We don't need to do anything else. Maybe I can factor cos x out over there. So I can go 2 minus x squared times cos x minus 4x sine x, so that it's more simplified. This is the second derivative of that function at the beginning. You notice that I applied product rule several times. This next one, it says find the slope of the normal line, okay, to the curve of this at x equals pi over 6. We know that normal line is perpendicular to the tangent line. So if I find the slope of the tangent and I find the negative reciprocal of the slope of tangent, that will be slope of the normal. We remember this from past. In other words, -1 over f prime at a would be the slope of the normal line. So first, I need to find the derivative. That's what I'm going to focus first. To find the derivative, I'm going to say this is a quotient, so derivative of top times bottom minus derivative of bottom times top. I'm applying quotient rule. So derivative of the top would be negative secant x tan x times the denominator would be tan squared of x minus the derivative of the bottom, which is secant squared of x, times the top, which is 1 minus secant of x, all over the denominator squared. Okay, so I'm going to simplify a little bit as much as I can. So I get negative secant of x tan squared of x minus secant squared of x. Negative times negative is positive. Secant cubed of x all over tangent squared of x. Okay. So now I think I can factor out, or maybe no, I can't factor. I'm just thinking of how we can simplify this using trig identities. So if I go 1 plus 10 squared is secant squared. So 1 plus tangent squared equals secant squared. So that means that tan squared is secant squared minus 1. So secant squared of x minus 1. I'm just applying the trig identities. Okay, and see what I'm going to end up with here. So negative secant cubed of x, if I distribute with that positive secant cubed of x, cancel out each other. That's good news. Negative times negative is positive. Secant of x minus secant squared of x over tangent squared of x. Okay. In the denominator, what else can we do? Tan squared is secant squared minus 1. So this is secant squared of x minus 1. This is secant of x minus secant squared of x. Okay. Can we further simplify this? Let's see how we can simplify this. In the numerator, for example, if I write 1 over cos, so this becomes 1 over cos x, 1 over cos squared of x. This would be 1 over cos squared of x minus 1. Common denominator in the numerator will be cos squared of x, so I end up with cos x minus 1 over cos squared, and that would cancel out with the cos squared at the bottom. So 1 minus cos squared of x is what I end up with in the denominator, which is actually sine squared of x, right? Sine squared of x, and that's cos x minus 1. I think that is all you can do. Or perhaps it would be better to simplify this. Hang on a second. We can write this as a negative 1 minus cos x. I'm just thinking to factor negative 1 out here. And the bottom is 1 minus cos x times 1 plus cos x, which is indeed difference of squares. And now we can cancel 1 minus cos x from top and bottom. So the final answer, negative 1 over 1 plus cos x, would be a simplified answer instead of using this other form. So perhaps this is a better way of simplifying. So, and making long story short, y prime is negative 1 over 1 plus cos x. Now I have to find the f prime at pi over 6. So negative 1 plus cosine of pi over 6. So cosine of 30-degree angle is square root of 3 over 2. So 1 plus root 3 over 2. If I do the common denominator, 2 plus root 3 and negative 2 at the top, this is the slope of tangent line. And all I have to do is to find the negative reciprocal, which would be m sub n. Flip this up, 2 plus root 3 divided by positive 2. So that is the final answer, which is the slope of the normal line. Now, I want to do another question there, but now I don't have enough room. So I have to leave it as an exercise for you, basically. So you do this question by yourself. It says find the slope of tangent at x equals 0 for this function y equals cosine of cube root of x plus secant of x to the 4 plus 3x. So you take the derivative basically and sub in 0, and that will be slope of tangent at x equals 0. Thank you very much.